Thanks for coming and thanks for having me. My name is Massimo Ferre. I'm a product manager at AWS. I'll talk in a minute about what I do at AWS and what this talk is about. First of all, I want to thank Daniel and the organization for both inviting me and putting all this effort to organize these kind of events, which I know are dragging a lot of resources and time from these people. So thank you for doing that. Also, thank you for the sponsors, without which this event would likely not be possible. So what do I do at AWS? That's an interesting thing. I usually say that I work on generative AI, but what does it mean, right? Everything is generative AI these days. So I'm not going to talk about these slides, but if we say generative AI in the context of AWS, there are a bunch of things, right? Infrastructure, Bedrock, Agent Core. I mean, you probably heard all of these things. This is the stuff that I'm working on, right? So I'm working on generative AI developer tools, which in AWS context means Amazon Q Developer and Kiro. How many of you have been using this product, just out of curiosity? A few of you. Okay. How many of you are using any generative AI coding tool in general? Okay. Many of you. Good, good. So what I'm going to talk about during this presentation is certainly from the lenses of these kind of things. So I'm not going to talk about like what life is in Bedrock or in this other part of the stack, even though some of the stuff that I'm going to talk about apply to that layer of the stack. And what I would like to talk about is both kind of the challenges and the opportunities in this space, right? And our experience in building these tools. It's not going to be a deep dive session. It's more going to be like a high level type of session. So I usually start, before we get into the meat of the content, I usually start with two slides. The first one is, where are we as an industry in 2025 from this perspective? And fact number one is, if you heard someone saying that they have figured it out, they're likely lying, right? And it's such a chaotic space. It's such a chaotic space. And one of the reasons why this is a chaotic space is fact number two: the pace of innovation is unprecedented. Right? I've been working in IT, you can tell from my gray hair, for more than 30 years, right? And I've never seen anything like this. As a matter of fact, I did some math, and I said, 1 year in generative AI equals 3 dog years, or 29 EC2 years. It's literally like that. It's literally chaotic like that, right? And I think that this applies to the industry as a whole and not just to AWS. We happen to play in this space. The second slide that I show is maybe a little bit controversial. I had to add an almost, because I realized that this is a little bit controversial, but forget almost everything that you know about computers when you get into this space, right? And what I mean by that is that if you look at some of the things that are a given in computer science, right? So, for example, determinism, right? I mean, you do A and you always get B. You do A, you always get B. I mean, it doesn't work like that in this space, right? So non-determinism is a very interesting challenge in this system. The reset number two that you need to do is this notion of backward compatibility versus evolving behaviors, right? I mean, if you imagine a system that is not deterministic when you don't change anything, imagine the nature of the system when you change something, right? It's going to be evolving over time, and this notion of I'm not getting what I was getting yesterday is very profound in this space, right? So we need to reset some of the expectations here. The reset number three is this notion of test versus evaluation. I have a slide that talks a little bit more about this. And the last one is this notion of fixing bugs versus steering behaviors, right? So we are in a mental model where if the behavior doesn't apply, or the behavior doesn't match what I'm expecting, I'm going to open a bug, right? In these systems, of course, there are going to be bugs in these tools, right? Because there are certain things that are simply bugs in the code or in the agent. But the nature of these tools is such that you do not fix bugs, but you steer the behavior of the system, right? So you understand the pattern of failure, right? Of things that you are getting constantly wrong or in the wrong way, and you try to steer the system to respond in a way that that makes more sense and that is more applicable to what you are doing. I'm just going to do a little bit of a deep dive in this test and evaluation because I've been spending personally a lot of time trying to figure out how to do these things, and it feels very close to my heart. And if you think about automating, does it work, right? So when you are in computer science and you need to test if a system is doing what it is supposed to be doing, right? We're coming from a background where you probably have tests or integration tests where you test your, software and artifact with a pipeline maybe, and basically the check that you do is it green, right? So if it's green, it does what it is supposed to do, right? In theory, right? And then we moved into a space that I call my dead AI, right? A few years ago. And there is this notion of, or example of, is this a dog or is it a cat, right? And this is pretty simple, right, to evaluate, right? Because you have ground truth, which is what this actually is. So you test the system, is this a dog or is it a cat? The ground truth says that this is a dog. So if you say a cat, it's wrong, right? So incredibly easy, or not incredibly easy, but relatively easy to evaluate this system. We are in a world where we are using these tools to generate thousands of lines of code, right? Literally, right? You use these tools to generate this amount of code, and you ask yourself, is it good? How do you evaluate this? It's very, very difficult to evaluate whether this system are good or not, right? Because the answer to these things is usually it depends. Or maybe there are dozens of ways why these thousands line of code could be awesome, right? So there isn't really a ground truth of this type of thing. So very, very challenging to do this kind of stuff. So the message here is reset your expectations. Let's get more into the meat of the presentation. And the way that I organize this is through some pills or very unstructured topic that I'm calling out in this agenda. So they're not strictly related to each other, but these are topics that I thought would be interesting to discuss and share with you when it comes to the experience that I had building this system. So let's start with kind of the easy one, which is how did we get here, where we are with these kind of coding agents, but agents in general, right? So my experience in this space started about 3 years ago, which in Gen AI is around 70 years. So I joke about the fact that I've been doing this job for 70 years because of the joke that I made at the beginning. But my experience started with basically, ChatGPT, as most of us, right? So back in what was November, December 2022, I started playing around with ChatGPT, and I thought, there is something big here, right? This thing is kind of, very, very interesting. And the way that it works is that you would ask question about a generic fact, right? And you would rely on the knowledge of the LLM, right? GPT at that time. Then we moved, very quickly into a space where instead of relying on generic knowledge, right, you would be able to bring your own kind of, documentation or knowledge is inside your organization. And this is probably, if you have been in this space for a long time, you heard the word RAG, and which is a way to kind of augment the knowledge of the system with private information. Where we are today is kind of a very, very different space, in my opinion, right? In terms of what you can actually do with these systems. And there are a couple of things that are very key to this, which is, first of all, the reasoning capability of the model. We moved to space where the value of these system and these agents was the knowledge that they had inside, to a place where the value of this system is how they reason about stuff, right? There was no reasoning at the beginning. And to make them reason, you really need to create workflows inside the agent to make them reason. Today, these LLMs are built to reason by default. The other thing that is very important that happened in the last year or so is this notion of tools, right? So the ability of the LLM to call a program that is outside of the LLM, that is part of the agent, that allows it to connect to the external world. These two things, the reasoning capability and the tools, which goes hand in hand, are two very important things that happened in the last year or so that are turning the capabilities not only of these coding agent that I'm working on, but in general to generative AI and all the agents that we can imagine. The other thing that is very, very important is this notion of the context, right? So we move from talking about RAG like as a way to bring in context or additional information into the agent to this notion of context. Why is context important? Is because of this kind of very important rule, right? And this applies to pretty much everything, not to Gen AI, just Gen AI. But if you have garbage in as an input, you get our garbage out as an output, right? So the better the input is, the better the output is, right? And this, again, applies to everything. It applies even more so to these agents and how they behave, right? So I'm not going to talk about these slides in many details because it's very, complex. But my message to you on this slide is, if you are getting into this space, and if you start playing with these, both coding agents, but agents in general, pay attention to everything that is discussed here, right? You will hear terms like, specialized agents, sub-agents, NCPs, short-term memory, long-term memory, steering rules files, very important. All these things are absolutely important to get that garbage in mitigated and improve that quality of the input so that the output always get better and better, right? And one of the challenge here is, how do you get all of this information, which could be like terabyte, right, of information potentially that you can get through tools, for example. How do you get that kind of information and distill it for what you're actually doing in your reasoning act, right? So that is one of the important things, right? Because one of the, typical things that is happening right now is, give me more like tokens and input, right? But this is not how we're going to scale these systems, right? Today, these models support like 1 million token as an input, which probably means, thousands of books or whatever. But this is not how this system works today best. And this is not how we're going to evolve this system, right? Do not expect to solve this problem by just taking like this gigantic amount of data and putting it into a 1 trillion tokens context, right? That is not how it's going to work. How it's going to work is, good context engineering means finding the smallest possible set of high signal tokens that maximize the likelihood of some desired outcome, right? And this comes from a very interesting paper from Anthropic that I'm linking there that you cannot read. But if you search for that, you will find it, right? The $1 million kind of input and 1 trillion, 1 million tokens input brings me to kind of the second topic that I wanted to discuss, which is agents pricing, right? I'm adding this to the presentation because, we have been through some of these challenges by building these tools, specifically QDeveloper and Kiro. But this is an industry kind of, challenge at the moment, right? And the challenge, if I was to summarize the challenge, is kind of the vendor and the user of these tools, like finger pointing each other, saying, that costs too much. Well, but it costs too much to run this stuff, right? If you look at this from the vendor perspective, it's kind of challenging, right? Especially if you're talking about these, big context window, because those are the things that drive cost of running this stuff, right? Running the LLMs, right? And so there is this kind of, dichotomy between these two, roles, right? The user of these tools and the provider of these tools, because the incentives is asymmetric, right? So if you think about the user, which is probably yourself, right? You are using these tools. What you want to have is a subscription level, right? Typically like in a Netflix kind of thing, right? I subscribe $20 a month and I get as many movies as I want, right? So you have those kind of expectations, fixed cost, clarity, from a vendor perspective, from the organization that are building this tool and are providing this tool, the challenges are opposite or different, right? How do I track the cost of these things so that I can pass them on to the user and maybe making a little bit of money out of that, right? Because this is kind of, what we're trying to do, right? So the incentive for the tool provider is, I would like to follow the cost of these things in a more pay-per-use model, tracking usage, sustainability, right? Because there is no point for a tool vendor, and I'm not talking about just about us, in general. And you have seen this, if you have been using these tools, you may have seen this by some pricing changes that created a lot of disappointment, right, in the community, in terms of how some of these tools has been changed in how they get priced, and the cost of buying this tool has been changing, which has been, kind of trying to create a more balanced way, to find this. And one of the reasons why I say that, nobody has really nailed it in the first slide is because I think that there is still work to do to create this kind of ideal solution that meets, these needs in the middle, right? It's still kind of, a work in progress, I would say, but I think that we're getting there at some point. The other topic that I wanted to talk about, which probably passionates me more than pricing, right? And maybe many of you, is this notion of English as a programming language, right? And I want to talk a little bit about spec-driven development in this context, but more broadly about what's happening. So if you think about the evolution of coding, and if you think about, like, you're probably all IDE users, right? You use the IDE. But if you think about the history of using the IDE, you may think about, starting from, it started with a very plain editor, and then it got into an IDE, and then autocomplete, and then inline suggestion, right? Inline suggestion is already some sort of, generative AI kind of feature, but it's more like basic, right? So for those of you that haven't used this, inline suggestion is you're typing in your IDE, like the new part of the code that you are writing, and the IDE would suggest, or the coding tool in the IDE would suggest what's the next, word, or what the next class that you are trying to build is. I divide the word in kind of, before ChatGPT and after ChatGPT, right? Pretty much like we divide the word as AD and before Christ. And with the advent of ChatGPT, things started to change pretty dramatically, right? So we started to see like these chat Q&A inside the IDE. This was still kind of very, very basic, right? Because you will have like a separate chat where you can ask questions about how do I connect to DynamoDB? How do I do X, Y, Z, whatever, right? And the LLM in a chat format would give you either the snippet of code or some information about how to do stuff, and you would just copy and paste that snippet of code into your editor, for example. And then we have seen this notion of agentic chat, right? Because of the tools that I discussed. So now the tools allows the LLM to get access to the IDE, to write files, and do all sorts of things. You do not need to copy and paste, but you would just say, build me something that does X, Y, Z, and it will just go out and do that inside your IDE, right? Very, very interesting. Where we are today is with this notion of spec-driven development. How many of you have been using some sort of spec-driven development or understand what spec-driven development is? Very few of you. Okay. I'll try to explain what that is in the next few slides. But let's start with the slide that I was presenting last year when I was doing some of these keynotes at community events. Because I want to give you like a little bit of history from where we are coming from and where we are today. The way that I was thinking about this framework of adoption for these tools, like it could be Amazon Q Developer, it could be Kiro, it could be Cursor, it could be Windsurf, Copilot, whatever you're using. But the notion is that there are two entities, right? There is the developer yourself, right? With a certain amount of knowledge for the task at hand, right? You're doing something and you have a certain knowledge about that thing. Maybe you are a big expert in Java, but you are happening to write something in Rust. So your level of knowledge is pretty low, right? It doesn't matter. It's like the task at hand that matter. And then, of course, there is the tool knowledge, the tool ability to help you in doing something, right? So you may be here at any point in time for your task at hand, and there is this very clear separation between you're in control and you're out of control, right? Because if your knowledge is here, anything that you're doing in this space, you don't know what you're doing, basically, right? Because you're out of control. You don't have the knowledge to understand whether what it is suggesting is good or bad, right? So there is also this notion of low return and high return. Of course, I mean, if I don't care about, the goodness of the suggestion, that is very high return, right? Because I can ask these tools, build me a new SAP competitor, right? And I have no idea how to build an SAP competitor, but this tool may help you build one. And so you are completely out of control, but big high return, because now you have an SAP competitor that you could sell, in theory, right? So the way that this framework works in my head is like there is a boost zone, right? You want to use this tool in this boost zone because you're still in control, right? And it's helping kind of, in figuring out what to do in a particular space. There is also a learning zone, right? You're out of control, but you're not super out of control. So you can use this additional information as a way to learn, like Rust or a new function in Rust, for example, because you're very close to being in control there. Where you do not want to be is in this danger zone, probably, right? Because you're completely losing control of what it is doing. It's going to suggest to you 1,000 lines of stuff that you do not understand, so you're going to commit them to Git. That's it, right? So you probably do not want to be there. You probably do not want to be in this limited value zone. And I characterize this as the time you're spending in prompting what you want is more than just going the IDE and do it, right? Basically. Right? So you want to gravitate around this area, right? This is kind of how I was thinking about a framework of adoption for these tools. You want to be in that green area. And then Andrei Karpathy, which I'm sure some of you know as kind of, the mind behind Tesla and the driving capabilities, and one of the co-founder of OpenAI, came out with this term of vibe coding, right? How many of you have heard vibe coding? Many of you. Okay, good. Vibe coding, in short, is this notion of, being completely out of control, right? So just prompt the thing to do stuff and accept them, right? That's it, right? So, I mean, he's probably right. I was probably wrong. But this is how it works, right? So imagine that you're starting with these tools where you're prompting to get something and you expect this artifact of code to be generated. The way that this works in vibe coding is pretty much like this, right? It will start creating some code, and then you keep prompting, and you keep prompting, and at some point it will derail, right? It will do something that is completely wrong, so you need to reprompt to bring it back to the correct rail, right? So that you end up having something that kind of works, right? So you're still out of control, but what you see it doing as an output, right? It kind of makes sense. Imagine kind of a web application where you see the result and you kind of say, this works, right? Maybe the code that has been produced is a piece of shit, right? Am I recorded? I am. Oh my God, I'm going to get into trouble, but yeah. But that's the point, right? So maybe it's not production ready, but for a prototype, it's amazing, right? Because you're getting into a prototype in like an hour, right? Instead of, if you're a PM, begging like a developer to, spend some time to build this thing that I've specified, right? And if you think about that, all this prompting and reprompting is part of that garbage in, garbage out, right? Because the first prompt is probably garbage, right? Say, build me XYZ. What does it mean, right? Completely garbage in, right? Because there are no information. So basically what you're doing is you keep prompting to add information, right? So that the output gets a little bit better, right? That's kind of how vibe coding works. Spec-driven development is a technique that is kind of different in nature, right? All the garbage in, garbage out applies, but the way that this works is different in the sense that the way that this works is that the first prompt will generate kind of these specifications, right? We'll get into what these specifications are in a moment, but this is how Kiro works, right? You can prompt it to do X, Y, Z, and it will build a bunch of specification that you can iterate on, right? So this is where you iterate on, right? Are these specifications correct for what I need to build, right? Once these specifications are done, and basically you're modeling your input here, right? You're trying to avoid the garbage in the input with this specification. You tell the model, go run it, right? Go build that thing. That's kind of the difference between vibe coding and spec-driven development. If you think about that, the parallel that I try to make is vibe coding is pretty much like, ClickOps, right? Inside the AWS console. You want to deploy something, you just do 100 clicks, you try, you delete, you recreate, whatever. You don't know what you're doing. But at the end, you get to a kind of the result that you want. You deploy something, right? Spec-driven development is this notion of like infrastructure as code. It could be CDK, it could be Terraform. I need to mention Terraform because Anton is there. He's not listening, but yeah. Right? The PM, the Kiro PM, what he came up with in terms of a parallel is vibe coding is like a gigantic Slack thread where you discuss what you want to build, whereas, and this applies more to Amazon and the way that we work, spec-driven development is like writing a 6-pagers for what you actually want to build, like a lot more structure around what you're trying to build. So for those of you that has been using Kiro, this may be familiar, but for those of you that has not been using Kiro, this is how Kiro works, right? I'm not going to get into all of these things, but one of the things that Kiro has is this notion of spec-driven development. And it's one of the key differentiator in Kiro these days. These are the specs, and these are the two options, right? So Kiro supports both a vibe mode, so you can use Kiro in the way that you use all the coding assistant, but there is also a way to use it in this spec mode, right? And the way spec mode works is as follows, right? So you click on spec mode, you prompt, build me XYZ, and what it will do is it will start creating a requirements.md file, right? The requirements.md file only has business requirements, right? The thing that you're trying to build inside your application, right? Build me a new feature that does this particular thing, right? And the way that this requirements.md works is that there are a number of requirements in this document with acceptance criteria, right? When this happens, the feature needs to do this thing, right? There is nothing technical in this document. It's like a product manager document, more or less, right? You can iterate on this because maybe you figure that the requirements are not just complete. So you may want to add requirements, or you may remove requirements, or you may tweak requirements. So you can iterate on this document, right? Once you're okay with this, it goes and builds a design.md file. The design.md file is kind of the input that talks about how architecturally this feature needs to work, how you are going to implement these. Use DynamoDB versus RDS. Use these versus this other thing, right? So more into the technical details of how you're going to build this feature. And these, if you remember the context that we discussed at the beginning, this is heavily influenced by the steering files that you have or the rules that you have, right? So separately, you may have in your assistant a bunch of rules that says, these are my standards, right? Inside the company or for my project or these kind of things, right? I use tab versus spaces, or I use spaces versus tab is kind of the ridiculous example of this thing. But the steering docs are very important to inform the LLM about, how you want the LLM to do things, right? And they influence the design.md. You can iterate on this, right? As an architect, as a developer, you have a say in these things. So you can iterate and you can change stuff in here. Once you're good, Kiro built a task MD, right? The task MD is kind of a rollout of the things that it needs to do to actually build that feature, right? There are maybe 5, 10, 15 different tasks that will get you through the final artifact that you're trying to build, right? And they are sequenced in a way that makes sense, and they map back to the requirement. You can see this, but each of these tasks has a mapping to the requirements. Like it says, this task will do this thing, and it will solve for this type of requirements back over there, right? And that's the whole notion of how spec-driven development works. This is where we are today, right? But if you think about, over time, how this is going to pan out potentially, right? Is imagine this notion of a source of truth, right? What is the source of truth for you today, right? When you work on code, is the code, right? That is what you commit to GitHub, right? You're not committing the prompt, right? Because the prompts are kind of ephemeral in a way, right? So there is this notion of source of truth and downstream artifacts. The downstream artifact could be like a build of my source code. That is ephemeral as well, right? Because you can keep building it and it will produce the same thing, right, in the end. If you put this on a trajectory of yesterday, today, tomorrow, and future, and by the way, I always point out that I characterize future as probably after I have retired, right? I want to put that in context, right? I'm not saying that this is going to happen like next year, even though next year is 29 EC2 years, so it may happen, But if you think about that, yesterday, it was kind of code was the source of truth, right? Of course. And you had inline suggestion in this assistant, right? Today, you have all these, of course, you still have inline suggestion, but you have vibe coding, spec-driven development. But the truth is that the code is still your source of truth, right? I mean, that is kind of the asset that you're producing, right? I say tomorrow, but we're already in this space where people are starting to kind of wonder, what are these specs, right? Are they part of the source of truth, right? Should I check them into GitHub for some reason, right? Should I keep them updated if I change the code later on outside of the context of spec-driven development? I mean, there is this confusion about right now about what these specs are, right? Are they documentation? What are they, right? Because today we use them just to build a feature, but it's a closed loop, right? But I imagine a future, and many are already talking about this, where the source of truth becomes the intent. So think about like a future where the code is just an artifact, right? A downstream artifact, right? Pretty much like today you write Java code and you build or compile that Java code into like an artifact. Imagine a world, and I speculate that this is coming after I have retired, where you check in and your source of truth is kind of the spec-driven development kind of artifact, right? Imagine kind of, this is pretty much like where we're going in terms of, long-term, um, uh, roadmap of the industry, right? And sometimes I'm wondering if we're already in that space. So this is Mark Burker. You may heard of Mark. Mark is VP engineering at Amazon, and this is what he tweeted a few months ago. I wrote a Monte Carlo simulator in Python. It took 300 seconds to run. I asked QCLI to translate it to Rust, compile and run, and it took 48 seconds. Right? Is Claude 4 the best Python compiler? You can already think about, what he did here is he went through intent to source of truth code, and then it asked the assistant to translate that Python code into Rust. But you can imagine a future where the assistant would go from the intent of writing that Monte Carlo simulation and compiling it into Rust. Just that's it, right? So in some sense, we are kind of already in that sort of future. I wanted to talk about a little bit also where we see these agents going over time. And here I'm specifically talking about coding agents, right? That class of agent. So if you think about where we are today in terms of agents trend, again, in the context of coding assistant, they are pretty much personal tools, right? So they augment your ability, your personal ability to do things faster, right? As we discussed. So they augment you as an individual. And this is kind of a proven domain, right? It's like somewhat mature, right? Even though because of what we said, like it's chaotic, but it's kind of mature and real, right? We're using these tools for real. I think that the next step is to use these tools as team tools, right? So instead of augmenting you personally, right? These tools and these agents and these assistants are going to help the tool the team as a whole, right? So becoming more of teammates rather than personal assistant that helps you doing stuff. And this is definitely a nascent domain, right? There are some attempts in the industry. Probably you heard about Devin and some of these tools, but they're not broadly used as some of the personal assistants. So I would qualify this as a kind of a nascent domain. If you dig into what this means from a technical perspective, next level details about this stuff. If you think about what you do today with this coding assistant, which apparently most of you are using, is like they live pretty much in the IDE, right? Typically they live in the IDE. There is an assistant in the IDE. It's bound to the developer. It's typically bound to a repository, right? So you work on that repository, and every developer kind of have the same setup, pretty much, right? So the thing that I was discussing moves this model to something which is a little bit different, right? Imagine everything decoupled from the developer, right? The developer is part of this kind of process, but these assistants are at the team level, right? You can refer to them, right, at the team level. They have a compute execution environment, which is not your laptop, right? So you can run in the background, for example, right? They have org knowledge, right? And this goes back to the context that I was discussing at the beginning. This is very, very important because these tools out of the box know nothing about you, right? So if Netflix is using those tools, if JP Morgan is using those tools, if you use these tools in your organization, they will all give you kind of the same answers, right? Because they know what the internet is telling them, right? So there is this whole notion of how do I create org knowledge so that this assistant can leverage like this knowledge about how my organization is actually working. And these tools are also ubiquitous, right? As I said, the developer is decoupled, right? So the assistant are team members that appear in Jira and GitLab and GitHub, wherever, right? Wherever you work, right? So you can ask them to help you to do something in one of those different channels. You can chat to them in via Slack, or you treat them more as a colleague rather than or a team member rather than like a personal assistant that is running on your own laptop, right? And this is just summarizing what I was saying, right? So these team tools are more asynchronous by nature, right? They run in the background. They're goal-oriented, whatever that means. I mean, this slide could be exploded in a 2 hours presentation on its own. They have high trust, right? So the main difference between these tools and those kind of tools is that these are very interactive, right? You are always kind of in control, right? Whereas in that world, kind of they have more, I joke about them having more bias for action, right? They just go do things, right? Because of some ground reality into the org knowledge, for example. So they know what they need to do. I'll close this with a couple of slides on this notion of, are they coming, for us, right? Because usually when you talk about this stuff, I mean, the next question is, are they going to replace developers, right? Because if you think about where this is going, I mean, like, are these things going to replace developers? Obviously, I don't have a good answer for that. Nobody knows. But I have thoughts, right? This is one of the slides. I think that part of it is a problem of mindset, right? I presented this slide many times last year, but I think that it's still valuable, right? This is an example of this SWE bench. You don't need to know what SWE bench is, but basically this is a benchmark that is an attempt to evaluate these tools, right? How good are these tools, right? The whole spirit of this, I'm going to give the tools like 1,000 of GitHub issues on a number of repositories. How many of them are able to fix, right? Out of these 1,000 repositories or 1,000 of issues, right? At some point in time, this number was 20%, right? I mean, today it may be 25, 27%. It doesn't matter, right? Let's say that these tools are able to solve 20% of the problems in those GitHub issues, right? And the problem of mindset is that I've seen people kind of approaching these in two very different ways. The first one is, they are 80% wrong, right? And yeah, they are 80% wrong. But the people that are successful in this space and they use this tool on a daily basis and are going to leapfrog those other people are those that say, oh, I can take all Fridays off from now to retirement. 20%, think about that. Monday through Friday, right? So I think that how you think about these things, it's always also influencing like what's going to happen in the future. I do like this tweet from this user where he or she, I don't remember, said, I want AI to do my laundry and dishes so that I can do art and writing, not for AI to do my art and writing so that I can do laundry and dishes. And this is very profound to me because this is the whole thing about removing undifferentiated heavy lifting that AWS has been good for, right? If I think about this in this way, it may make more sense, right, to use these tools. And I wouldn't see this tool as threatening me, right? The other thing, and some of these are a little bit disconnected, right? So I'm jumping a little bit like left and right. But the other thought that I had is like, what if these tools are just like a new abstraction to what I'm doing, right? So think about the infrastructure as code landscape, right? Infrastructure as code started with, in the AWS context, like CloudFormation, 1 million lines of code to deploy an EC2 instance pretty much today, right? More or less. And the language was JSON, YAML, DSL, whatever, right? At that level, right? And then we introduced CDK, right? Which was an abstraction level on top of CloudFormation, if you think about that, right? Where the main difference is that like you can write things in Python, TypeScript, whatever is supported, right? So a different language, right? To do the same thing in a different way. What if this is just a different language, right? Where the language happens to be English instead of, a programming language, right? This goes back to that intent being the source of truth, right? This is far out, but think about this as kind of, an evolution of what we're doing today instead of like, oh my God, the world is melting, right? And this brings me to the last slide of the session, which is I think that the role of the developer will change. It will not disappear, but it will drastically change for sure, right? But if you step back and if you think about what happened in the last 50, 100 years, right, it's no different from what happened at that time, right? Maybe our grandfathers were doing this and today we're doing this, right? So completely different tools. The example that I think applies best to us is that 20 years ago we had these guys, at least this is in Italy, we had these guys you know, at the toll station, getting money when you go through the highway, right? These guys today no longer exist, or few of them exist, because now are engineers that are building this stuff, right? So it will evolve over time, but in my opinion, it doesn't mean that we will need less people, right? Definitely, we will need people with completely different type of skills and attitude, but it's not like we're going to need less people. Thank you. This is the feedback link. As Daniel said at the beginning, please use the feedback link to give us feedback. If you like it, if you don't like it, what can be improved. It's important especially for the people that are organizing this event. Thanks for coming.